In this video, I'm testing Antinsky Engineering SG resin. Antinsky sent me this resin for free for testing, which was very kind of them, but they had no say in how I was going to test the resin. So for this video, I've developed some new tests using my torque wrench, plus the weight test, and then we'll see how this resin prints when making parts that I actually need. Let's get straight into it. In this first test, I've made this 24mm socket to see how much I can tighten up this disc rotor using this lock ring tool. The imperial scale on this torque wrench goes up in nice round increments of 5 foot-pounds, so I'll be using that and then showing the metric conversion. Here we go, starting with 5 foot-pounds. No problem. 10 foot-pounds. Still strong. 15 foot-pounds. Not breaking yet. 20 foot-pounds. Let's check that and try it again. Yeah, okay, so failure occurs at around 20 foot-pounds or 27.1 Newton meters. Now for a socket that's made of resin, that's looking very promising. And to be fair, this is a large socket grabbing onto a large lock ring tool, so I was expecting this to work reasonably well. In this next test, I've made a 17mm socket to see how much I can tighten this M10 nut. Now I'm expecting this not to be as successful because the nut is much smaller than the lock ring tool, which gives the socket less to grab onto, at least that's my theory. And perhaps that wouldn't matter so much if it was made of metal. So let's see how this goes. 5 foot-pounds? Well, that seems to be working just fine. 10 foot-pounds. Okay, so we're getting some slippage now, as the resin doesn't seem to be able to grip the nut as well. We'll try it a bit more. And yes, so there's the failure. So not as good on that one, but still kind of okay, maybe? In this test, I've made an 8mm hex drive socket, and I'm expecting this one to suffer significantly from torsional stress. But let's see how it goes anyway. And you can see here that as soon as I start tightening, the print starts twisting. And look, that was very predictable. It's a lot to expect from resin. But it's still a fun test to do. For the next test, I made this eye nut to test two properties: how well you can tap threads into this resin, and will that thread hold my weight? I'm using an M10 tapping tool, and you can see here that the resin takes a thread really well. I wasn't expecting any kind of resistance when tapping, but I did wonder whether it would tap cleanly and not strip in any way. And you can see that it threads beautifully, and you can easily tighten a bolt into it. Now for the weight. Using this simple rig, I tested both sitting weight and fully suspended weight. I weigh about 85 kilograms, and you can see that it easily takes the weight when seated, which of course is much less than 85 kilos, and I totally expected that to work. But the eye nut also takes my fully suspended weight. Now I wasn't expecting the ring to break or fracture. I was more concerned about the thread just stripping out and sending me to the floor. Now this isn't a very dynamic load, and I'd need proper lab equipment to get more accurate results, of course. Although, in the absence of having a safer way to test heavier weight, I'd say this result is very encouraging. Now, what about using this resin for a part that I actually need? This is a dust port fitting that I've made for a circular saw. And let me say right up front that for a black resin, this print finish looks really good. This part needs to retain its shape in use, but still be able to handle some knocks, wear and tear kind of damage, chips and cracks, that kind of thing. So using my usual drop test, I drop this 1.5 kilogram hammer onto the part with its own weight, at least 10 times. Now the impact testing results for this resin are excellent. The hammer bounces off the part without any cracking or chipping. There are visible scuff marks, and look, that's to be expected, but the part withstands constant hammer blows with ease. It also maintains its shape really well, not showing any signs of deformation. So if you need a part that can handle some impact, then this resin will probably work very well for you. I really did think that this was quite impressive in testing. Then I do the vice test. Now, I know the part will break in this test, of course it will, but it's how it breaks that's of interest. The engineering resins tend to hold their shape better and then break suddenly. Tough resins, on the other hand, tend to squash right up and then split. Well, at least that's my experience. Typical of the engineering resins that I've tried, this resin does hold its shape quite well under pressure before cracking. Now, of course, it is bending as the vise is closing, but you can see that it takes a lot of pressure before suddenly cracking. So again, a very impressive result compared with non-engineering or non-tough resins. So what do we make of all these tests? Well, for an engineering resin, you could conduct thousands of tests to try and cover all possible use cases. But after having tested so many tough or engineering type resins, I'm just starting to wonder whether most people just want a resin that's not going to break easily. Now sure, some people will have a specific use case which requires a specific resin and specific testing. But for the most part, if you're into prototyping or developing your own parts that need to withstand some punishment, well then I'd say that this resin is definitely worth considering. Now 2 things that might put you off, and I have said the same thing about other engineering resins. The price. It's at the more expensive end of resins, but then as you can see it's also very capable and, well, you get what you pay for. And it's black. That's the only colour. And that's totally fine if you like black. Now something else I'll mention is that this resin is very thick and viscous. Now I found that printing was much easier when the resin was pre-warmed and the printing conditions were up around 30 degrees in the printer. So even though it's summer here right now and quite warm, I did pre-warm the resin using this heater mixer when doing tests first thing in the morning. There's a link in the description if you'd like to know more about this resin and how to buy it, and also for this heater mixer. Once again, I'd like to thank Antinsky for this opportunity. It's always fun to do tests like this and just get a sense of how much these resins are improving. And if you got value out of that, then it'd be great if you could hit the like button, leave a comment, and consider subscribing. Thank you so much for watching, and we'll see you next time.